after this session is over, try to search it on internet. Have you seen any monocoque chassis? Yes, you might have seen, and most of you would be knowing that. But yes, what is exactly monocoque chassis? How and why it is considered to be useful in passenger cars, or every car that you have, except for the Jeeps and all, every car that you have at your home almost has monocoque chassis. So the Jeeps, they do not have monocoque chassis. They have the ladder frame. So we'll discuss more on day 3 about the chassis and body. Then we have the next automotive system, wheels and tires. Okay. Your vehicle design is good. You have a powerful engine. You have a good suspension. But tell me, will it be possible for anybody to run the vehicle without having wheels and tires? No, it won't be possible. So the system that keeps the vehicle in contact with the road and provide necessary traction is the wheel and tire. And basically, from traction, I mean the grip between the road and the tire. So in order to run our vehicle, we need to have some friction, some traction. So suppose there is no friction at all, will it be possible for the vehicle to run and show a controlled motion? Just try to imagine that, if it is possible. What I'm saying is, if there is no friction, the surface is frictionless, will you be able to run the vehicle in a controlled manner? Just try to explore that option. Okay, since this is tire and it remains with the in contact with the ground all the times, it makes use of a lot of components. Yes, first of all, there is a rim on which the tire is mounted, and then after that there is a hub on which rim is mounted, and on that hub there is a upright on which the suspension assembly is mounted, and in inboard braking you have the disc and caliper and several bearings and circlips, everything. So that is your wheel assembly. So in wheels and tires we mainly intend to imagine, okay, how our vehicle will be performing when we provide certain load or certain power input to it. So let's say there are various types of tires. For the day 3 we have this session also. There are radial tire, there are bias tires, and there are tires used in two-wheelers, four-wheelers, trucks, buses. So the configuration of tire, the design of tire changes as per the load requirement and as per the speed requirement. We will see what is tire nomenclature and what is tire terminology when we actually discuss this. So as of now, you can note that there is a hub and wheel hub basically, and you can look over for its design, how it is attached. So on day 3, I'll show you the actual wheel assembly also, and the hub also, and the upright also. So far, as of now, you just try to see there is a rim, and over that rim there is a tire, and that rim is mounted on a hub, and that hub is mounted. This part is your hub, and this part is your upright. So basically the hub and upright, they are fixed together. They are press fitted, and they, it is like that this hub, this upright, it stays stationary and this hub rotates. So in order to rotate, there must be a bearing. So this is the bearing, and bearing brackets and bearing locus given over here. Then this is your brake rotor or brake disc, and this is your caliper, and this is the check nut, and this is the pin, quarter pin. So we'll see the assembly in detail. Do you know the components of wheel assembly? These are the components that I just told you. These are the components of the wheel assembly. Then we have the suspension system. So what is a suspension system? Suspension system is something that isolates the road loads from the chassis and maintains the ride height. What is road load? Suppose you're going on a track and that has bumps, that has pits, that is very irregular. Like that is a cross country road. The road is not very smooth. Then there are two vehicles running. One is a tractor and one is a car. So you will feel that you are more comfortable inside the car. Why? Because you have suspension. You will feel that the ride is way smoother than that of the tractor. And in cars also, you have hatchback, you have sedan, you have SUVs and MUVs. In SUVs, when you are going on these kind of roads, you will feel that you are more comfortable. So that is nothing but your suspension. That job is done by the suspension system. The job of suspension system is not only to provide a comfortable ride, but also to maintain a ride height. What exactly is the ride height? We will discuss when we discuss the suspension system in detail. So ride height, ground clearance, suspension or shock absorbing effect. Basically, these are some jobs of the suspension system. And also, in order to control the vehicle's movement, we need to have the suspension and steering systems coordination. So suppose you are running a tractor, you are driving a tractor, and the tractor goes on the off-road surface or a multiple number of speed breakers repeatedly. So you will feel that your steering is not stable. You just try that on a relatively larger speed of like 30 to 40 kmph, and as soon as you hit these speed breakers repeatedly, you will feel that this effect or this jerk is being felt on the steering wheel, and that will create this bump steer or roll steer. What is these? What bump steer and roll steer? We will discuss that on later sessions. So far, you just consider that your steering is largely dependent on the suspension system. Okay. Do you know the components of a shock absorber? Just note this question down. Components of a shock absorber. A shock absorber looks like it is a one component itself, but no, it is an assembly and it has various components. From components, it could be a piston, it could be a cylinder, it could be anything. So just try to imagine, try to explore what are the components of a shock absorber. All right. Then going further, we have the brake system. In brake system, we have disc brakes, we have drum brakes, but yes, we need to consider on what principle does this brake system work, or what is the physics behind the brakes. So brake system can be defined the system that makes use of friction to slow down or stop the vehicle as and when required is a brake system. And what does it do? It has a friction surface that is known as your brake pads, or that is known as your brake shoe, that rub against the rotating surface. In a case of disc brake, it rubs against the rotor, and in case of drum, it rubs against the drum surface. So this friction creates a lot of heat and it slows down the vehicle. So this is the basic working of the brake system. We do have a detailed discussion session of the brakes, and then we will see with the help of the animations and videos how exactly this brake system works, what are the components of a brake assembly, and how exactly they are attached, and what is the physics of braking or brakes. So you just explore this option also. Then we have the automotive systems as steering system. Okay. You have so far frame and body, you have the wheels and tire, and you have the suspension also. You have the suspension and brakes. So steering is required to turn the vehicle in a controlled manner. System that enables any vehicle to undergo a controlled turn is known as the steering system. So it makes use of a steering gearbox and certain links and a steering wheel and column and some universal joints, and that will comprise of your steering system. We do have a detailed discussion about the steering system. As of now, you just understand that when you rotate the steering wheel, just imagine when you are rotating the steering wheel or when you are actually turning up the handle. So basically you are commanding your tires to go into left or into right direction. That makes the turn possible. So this left and right turn of the tire is the arrangement of several gearboxes and links. So you will see that here it is a rack and pinion gearbox. And then there are two links. These links are known as the tie rods. And then there are some other components also like the ball joints and the rod ends. If we connect them together in a designed manner in a specific geometry, then we will possibly undergo a controlled turn. From control turn, I mean, we want to have the desired turn. And sometimes it happens that vehicle goes oversteer or understeer. So when we discuss the steering system in detail, we will also study what is understeer and what is oversteer. So that is a later part to be discussed. For now, your question should be, what is the steering ratio? And the steering ratio is something that should relate with the amount of turn that you are giving to the steering wheel, and that amount of turn that actually the tire is turning. So you should explore what is the steering ratio, and you should also explore what possibly could be the parts of the steering components.